Good afternoon, everybody. Welcome back to class. Hope you guys are doing really well. And just have, about 5 minutes, and then we'll get today's meeting going. But I hope you've been having a good week since I saw you guys last Wednesday. And just get comfortable and get ready to take in a few more notes on a new chapter of the book. Hi, Mateo. Good to see you. Hi, Adeline. Hope you're doing well as well. Hi, Kayla. Yeah, it's always nice to see you guys. Feel free to toss in some comments or say hello anytime. It's an interesting week with the Jillian. Yeah. Which message? I have a lot of them coming in. I might have had a note to get back to it later this afternoon. Was it something urgent? If so, just feel free to let me know here in the chat while we were together. It's just like a grade check request. The outcome of the quiz, yeah, not to worry, Jillian. It's not like a special situation where there's like a delivery issue or anything. You're just asking for the grade, basically, right? Yeah, I'll give you your score. I've been kind of preoccupied the past few days. I got through a whole batch of emails as of Monday night, but then yesterday with the election day, I kind of had to wait to go vote, and I was, watching the news and stuff in the evening. So my plan is to clear my inbox of all new messages before the end of the day tomorrow. So not to worry, you're going to get that reply from me, and I've seen it that you've sent the message, but I'm going to get to everyone all at once in the tail end of today and in the morning tomorrow. So look out for my message in the next day or so. But not to worry, because there's nothing urgent on the timeline coming up soon. You do have a homework that's due next Wednesday, but it's plenty of time between now and then. And I posted the answer key at least, so at least for now you can check your scores against the answer key. It's pretty easy to calculate, but I will give you your official score and any other scores that you want. Okay, but thank you. Yeah, we're in definitely a kind of interesting moment in, I guess, our history and in this country. We kind of don't exactly have clarity per se on the outcome of the election, but it seems that it's going to be Biden. So, not every day there's a one-term president. In your guys' whole lifetime, that hasn't happened. I'm old enough to remember the first George Bush, and he lost to Clinton after his first term. But we've seen no other case since then. 2 terms for Clinton, 2 terms for W. Bush, 2 terms for Obama. So yeah, it's quite a development, but we're all watching the news, so that's something looming in the background, obviously. Hey guys, good to see you. Lena, Clarissa, Kimberly, everybody else. Yeah, I've seen different numbers, Alex. I've seen, it depends on the news organization. Some are more or less comfortable calling some states based on the data they have than others. But yeah, I've seen the number vary between 248 and even 264. So yeah, and then Kimberly, for our project, can we use the same company for our project but use their different commercials to show the 20 fallacies? Well, if you have like a single company that has done, that many fallacies in their different ads, then I suppose that would be fine. I don't mind if it's the same company, but you just have to make sure not to double count the same fallacy, right? So you got to cycle through to the next one. Only one example of that kind per fallacy. But yeah, there must be a company that you know of that's just cranking out. Yeah, not all fallacies are in one ad. Oh no, for sure. Well, I'm a little confused now. I mean, definitely you got to turn in 20 different advertisements, right? So in no case would you only turn in one ad. You're going to find 20 of them, and you're going to find 20 from wherever you can find them in the media, online, in printed materials. I used to do this assignment as an in-class activity, because when we used to have physical meetings, I would have every student come in with a magazine, and they would work in groups. And what the groups would do, I would put you guys in like groups of 3 or 4, and you'd all cut out examples of advertisements that you see in the marketing and advertisements of the magazine, and then you'd simply submit that to me, so it would all get done in like one class period. Well, now it's a take-home, individual assignment, but the basics of it are similar. You just have to, Yeah, it was kind of fun. It got you guys a chance to talk to each other and kind of communicate about it and compare notes and compare your examples. But we'll do the best we can with the limitations that we've got. That means that you'll just be doing it as a work assignment at home. But there's some advantages to that too. And it was just in class, you're limited to these physical paper magazines. Now that you're at home, you've got the access to the whole internet, and you can use video clips and links. So, I mean, that's, I guess, kind of a nice benefit of it. And then, hey there, Miguel. Okay, so welcome back, everybody. It's 2:30. Let me just start off with a couple of basic announcements or updates about the class. So thanks for being here again. As I'm sure everyone knows, we kind of had a break from the lecture on Monday. I wanted to show some videos that kind of give a sense of critical analysis of the media, how fallacies are sometimes found in media reporting, but also in advertising and marketing materials. And then that sort of sets you up for the upcoming homework assignment. So I slightly adjusted the due date. Make sure you noticed that in the announcement that I sent on Titanium. But next Wednesday, the 11th, that's a week from today, you'll basically be sending in to me your third homework assignment. And the third homework assignment is just, you've got to find examples of fallacies in advertising and marketing. So sometimes these are seen in like full color glossy print magazines. You see a bunch of like advertisements for clothing and fashion lines and like fragrances or other consumer products. So those are easily found in physical print journalism and in magazines. You'll also, of course, see those in digital advertisements that are posted online. So there will probably be a lot of students that find YouTube clips and stuff of different commercials. Well, anyway, you have to basically compile a set of, at most, 20 fallacies. And for each fallacy that you find an example of, I'll give you 5 points for that example. So 20 times 5 is 100. If you get all 20 of these examples, then you're going to get 100 points added to your score for the semester. But there's a couple of basic ground rules. All this is mentioned in the announcement that I sent, so you can always verify or double check against that, the things that I'm saying now. But just to speak to you here in person, you got to compile that list. That's one thing. Now here are some rules. You can't use a single fallacy more than once. So it's not like you cannot turn into me 20 examples of the naturalistic fallacy or something. Like that would not count. So once you've gotten one example that you feel is clear, it's on to the next, and you're trying to get all 20 by doing that. You also have to create a short document, and the document is going to be associated with the set of examples that you've given me. And what you're going to do in the document is you're just going to write like a one-sentence explanation for every example you gave, where you said, here the fallacy of blank is in this ad. You're just going to write one-sentence explanation or a description of why you say that is in that advertisement. Okay, so you have to justify your judgment that that was a fallacy of whatever that the ad had. Okay, and of course me, the grader, the judge, the teacher, when I see your work and I'm looking at it, I'm going to evaluate, did the student actually give a correct example of the fallacy? And depending on if it's correct or not, hopefully it is, then you get 5 points. If I thought there was something a little off about it, like you're trying to talk about like red herring, but it's actually, I don't know, ad hominem or something, then I would say, well, this is not a match. The example doesn't match the explanation, so there's some kind of deduction of full credit for that example. But anyway, that's it. Your task, your job for this assignment is go out online or by taking pictures of ads that you see physically or any combination of those. Send me a full list of examples. If you find that you're using links and stuff, just have to include the link so that I can click on it and view it. And once I've seen your examples and I grade them, then that's your third homework. Okay. I don't know if there's anything I didn't mention about it, but are there any other questions about that assignment? If so, feel free to let me know and ask, and I could expand on this or something, or tell you any more detail if you want. But it is the third homework assignment. Just like the first two homework assignments were worth 100 points, so is this one. And then after that, there will just be one more homework assignment later in the semester, and we just have one more quiz, and then the final. Is there a minimum that I'm looking for? Well, I mean, 20 times 5 is 100 points. There's no minimum. You can not do it at all and then just get 0 points, or you could do one of them and you get 5 points. It's really up to you. If I was you, I would want to do all 20, because each one that you do that's less than 20 is less points, right? So if you did 19 and you got them all right, then you get 95 points. If you did 18, you're getting 90 points. So multiply by 5 the number of examples that you want to turn in, and that's how many points you can get. So it's totally up to a student. I mean, I would assume you want to get as many points as you can get, but no, there's no minimum. Feel free to not do it, and then just not going to get any points. But does that make sense? You know what I'm saying? I mean, there is no minimum is the answer. But do you understand that it's in your best interests to do the maximum? You should always do the maximum in life, no matter what it is. Doing the minimum, that's weak. Doing the minimum is like the least you can do. You try to do the most you can do. Just a general rule. That's how I try to live. But anyways, we're all different people. That's all good. So, fair enough. Then, unless there's other questions about this, we can set it aside for the moment, and I'll get into our lesson for today. We've got a new chapter of the book that we're going to try and start on. But okay, good. I was just confused because it sounded like an extra credit assignment. Oh, no, it isn't. It's a real homework assignment. You'll see it in the syllabus. The original date that I provided in the syllabus was Monday, the 9th. Dying in sleep. Yeah, well, I'm definitely a big sleeper, so I can relate to that. Not dead yet, but once I am, I'm going all in. Okay. But anyway, yeah, so let's do this. We've got a new chapter to talk about. And it's chapter 12, and it's all about science and its not so nice evil step brother or sister or twin, pseudoscience. So science and pseudoscience. Science and pseudoscience. So this is the chapter in the book where we're really going to take a quick critical examination of science. What's the history of science? What are some fundamentally important concepts in terms of the scientific method? What are some of the basic assumptions that science makes? And how can we tell the difference between like real, legitimate, credible scientific theory and research and misleading and false scientific information, which is called pseudoscience. Pseudoscience is like a fancy sounding word, but it really just means like fake science. It's something that claims to be scientific, but it's actually presented in a way that departs from the scientific method and the principles of empirical research. So we're going to learn how to distinguish between credible and just junk science, but that means that we're going to have to start at the beginning. So we'll start by just talking a little about the history of science in the West. First, though, I guess I'll refer to some of the opening information at the beginning of the chapter, because as with many of the chapters of this textbook, they kind of start off by referring to something that's a little bit like a real-world thing to bring the reader into a sort of interest in the topic and to just sort of supply that stimulation for the general interest in the topic. So in chapter 12 of our book, which starts on page 361, they begin by mentioning the much discussed issue of global warming and climate change. As you guys probably all know, because you're young people, and this is a current phenomenon that's really accelerating now, we have a problem in the world with the heating of the climate, and it's the result of accumulating greenhouse gases in the Earth's atmosphere. Why are those greenhouse gases accumulating in the Earth's atmosphere? Well, they're doing that because of human activity in large part, and the trapping of these greenhouse gases are produced by waste products from human industry, and in some cases from like fossil fuels and energy production. So the greenhouse gases that get emitted from these industrial processes, they remain in the Earth's atmosphere and they get trapped there, and that ends up trapping heat, which I like the heat. I prefer it to the cold, but the problem is that it's the whole globe that gets hot. It's not just like a hot summer day, which maybe is pleasant, but it's the whole globe, including like the Arctic ice caps that get hotter. And what that is causing to happen, among other things, is a rise in the global a rise in global sea levels because of the melting Arctic sea ice. And if you just study the trends, we've had significant sea level rise of at least 7 inches over the past century. So water being released from these previously frozen ice caps is becoming a part of the ocean and causing the levels to rise. That's a concern because according to certain models that project what could happen over the next century, before we get to the 2100s, if this sea level rise continues without any kind of intervention or mitigation by us, then at least even conservative estimates say that it could rise by as much as another foot before we get to the end of the century. And if that happens, it's kind of scary because if you imagine worst case scenarios, whole coastal regions could be significantly compromised or even underwater. And here I am, and I'm in Long Beach, which is right up near the beach, and a lot of us living in California, I suppose most of us are, we inhabit places geographically that are kind of coastal, or at least not too far from the coast. So we have to worry about significant impacts on human society, civilization, and all of that as a response to our man-made climate change. In recent decades, the heating trend of climate change has accelerated. So it's not like it's just staying steady or it's declining. It keeps on going right up. And if you were to look at a graph of like all the hottest years globally, since we started keeping this data in the later 1800s, meteorological data about global temperature, it seems that all of the hottest years ever recorded are all clustered towards the end of that timeline, like closer to the present day. So like the hottest 14 years ever recorded have all been since the year 2000. And some of the hottest years on record are just the past couple of years, like 2019, 2018. We seem to keep setting a record for hottest year every year. It's like either hottest year or second hottest. So that's a concern. As critical thinkers, we have to be able to interpret and evaluate information that we hear from scientific research in the media, in scientific journals, and from learned people, professors, and others who are qualified to talk about that stuff. We also want to know how to do our own research, how to follow the steps of the scientific method. So yeah, again, we have some goals in this chapter to talk about the history of science, identify some of the assumptions that are built into it, study the scientific method, and distinguish between real and fake science. Okay, so first of all, what is science? Okay, so like the knowledge chapter, it started with the definition of knowledge. The language chapter starts with the definition of language. So as we're going to sort of telescope in from the biggest, broadest characterization of the subject, we'll just start with what is science itself. And as the book defines it, I think it's a fair definition. It's reasoning from observable facts to testable explanations for the facts. So yeah, it's a little bit of a too big of an R. All right, reasoning from observable facts to testable explanations for the facts. Science is all about explanation. It's about explaining cause and effect, why something is happening, okay? So the product that science tries to generate, the whole goal behind it is to get to an explanation for how something works. And then once we've given that scientific explanation, we've learned something and something valuable. Maybe that allows us to control certain processes. Maybe that allows us to prevent certain outcomes that we don't want. But we need to understand things. As human beings, we have the brain and the power of mind to do that. And science is the best tool that we can use for discovering truth. It's the primary source of knowledge about the world. So if there's anything you're curious to know about, like, how does volcano work? Or, what is a shooting star? Or, why does a helium balloon like float, but like one that's just filled with oxygen doesn't? If there's any question that you have, how does entropy work? What is the nature of photosynthesis? I mean, any question that you have a deep interest in. If you want to get a real answer, not just something that is coming from a non-specialist or something that's, not fully detailed, you would go to science, and the most high quality explanation for any kind of physical question would be a scientific answer. So it's huge. It's a tool that we have to use to learn about the world, and thankfully for us, we have generations and generations of scientific knowledge that's already behind us that we can now just build on and expand upon. So in that sense, it's a kind of good time to be alive. And yeah, like, so imagine that we didn't have science. I mean, go back to like primitive time of human beings. They would see, you know, maybe like an earthquake, and it's just like, whoa, what's happening? I have no idea, right? It's just something's shaking. Or, you know, all of a sudden something covers up the sun and it's like dark all the time. It's dark for a little while, but it was just daytime a minute ago, you know, an eclipse. And people are like, what's happening? Is God mad at us? Is this the end of the world? Stuff will happen, but if you don't have a scientific explanation, you're just sort of confused. Like, why did it happen? I have no idea. Intelligent people, critical thinkers, and scientists, they don't want to just sort of see stuff happen and be like, crazy. No, they want to know why it happens, right? We talked about this earlier when we talked about the steps in the critical thinking process, and science and critical thinking are very similar. Critical thinking is a more general concept, but science is towards cause and effect and physical explanations. So without science, we'd be at a loss, is what I'm telling you. I mean, we would exist like animals exist, but we would just be kind of like living, dying, eating, sleeping, but without any deep insight, and therefore, you know, we'd be more like animals than what human beings are. So it's part of our, I guess, great privilege as humans to have the ability to think scientifically and to understand the world on a deeper level. So let's go back in time a little and give you a sense of some historically important moments in the history of science. Oh, and the last thing about that definition, we're trying to get to testable explanations. So we want to have an explanation, but we don't want you to just have to take our word for it. In science, the scientist says, well, here's the explanation, and by the way, you can tell by yourself by conducting an experiment. So we want explanations for stuff that are so clear and precise that we could test the explanation with an experiment. Okay, so experimental proof of a theory is a major part of science. Science is not supposed to be, and good science isn't, people just saying stuff and saying, you can't prove me wrong, and what I say is just absolute truth. A scientist always has to provide some way of the claim being verified through experiment. So experiment, observation, and testing is major to science. Okay, so let's go back a little bit. Before the 17th century in the Western world, science wasn't really the dominant way of trying to discover truth. The church was kind of like the preeminent institution for the whole early Christian era and the medieval period. But as we get into like the 17th century, after the Renaissance and in the centuries following that, the church starts to kind of lose its firm grasp over the functioning of society. So like the division of church and state starts to exist a little bit more, and people are now starting to develop scientific knowledge based on observation and experiment instead of just by adhering to orthodox doctrines of the church. But that produced some conflicts and tensions between science and religion. For example, this is a famous figure in early Western science. It's Nicholas Copernicus. Let me write his name here. I want to double check something because I always get, this is always a little frustrating to me. Okay, yeah, there we go. The spelling of the name. Sometimes I've misspelled it during these lessons, so I'm double checking myself. Yeah, Nicholas Copernicus. So he lived from 1473 until 1543. And he was, well, let me tell you, he was a Polish astronomer who basically discovered something very important and perhaps revolutionary. It's called the heliocentric model of the solar system. And this is important because it replaced the older way of looking at the universe, which was called geocentrism. Okay, so what do you think these words mean? I bet you can come up with the right inference, even if you're not 100% informed about the history here. Does anybody know? What does it mean to discover heliocentrism? Or you could say the heliocentric model of the solar system. What would that be? To discover this, which replaces geocentrism, any thoughts? What could geocentrism have been? What do you believe is heliocentrism that replaced it? Okay, good, Judy, yes. Heliocentrism is the widely acknowledged fact that we all know today, which is that the sun is at the center of our local cosmos, and we rotate and revolve around it. The Earth rotates around the sun, not the other way around. That's what Copernicus and also Galileo were able to discover using newly invented telescopes. So telescopes have not always existed, but the sort of lenses and the oval shape of them that allowed for greater magnification of the celestial bodies and space, that starts to be developed in the this time period, right? And sort of in the era in which he lived. So he's finally one of the first people in the first generation that can like use these new telescopes to examine more closely the motions of the planets in our local cosmos. And by means of his observations, he was able to prove really that it's not the sun, sorry, it's not the Earth that's at the center, it's the sun. Now before him and before Galileo, geocentrism was believed. Do you have a thought about what does geocentrism mean? So you're right, heliocentrism is sun is in the middle. But what do you believe was geocentrism, which heliocentrism replaced? That the Earth is in the middle. That's right, Andrew. Geo meaning Earth, so geocentric, centrism meaning placed in the middle. Now here's the thing, it actually was not, it was considered very important to the church and to the people who held power at the time to keep this idea in place, that the Earth is in the middle. That was considered important because according to their interpretation of religious orthodoxy, God, God's the creator of the universe. And if God creates the universe and we are the children of God created in his image, which are all ideas stated in the Bible, then you would think that God would place the planet of human beings, Earth, in the middle of everything, right? Because if it's mankind who's been created by God for the sake of being in his image, and if this whole universe is really just created as a place for us to inhabit, then we should have like a kind of privileged position where everything revolves around us. And so it was actually considered offensive to the religious orthodox views at the time to hold this claim of heliocentrism. So much so that authority figures persecuted, well, maybe not so much Copernicus, but Galileo, who was finding the same things. He was persecuted by the church, even though he was very old and like half blind because he was looking at the sun through telescopes and stuff back then. He also discovered, along with Copernicus, this fact about heliocentrism, and it was considered, yes, it means that the sun is in the middle, at the center. That's heliocentric. Geocentric means that the Earth is at the middle. But if we follow, the little narrative here, before Copernicus and Galileo, it was believed that the Earth was in the center because they were deferring to the ideas of religion, according to their interpretation of which God would want us to be in the middle because, we're his children. We're not just random things evolved somehow in the universe, but given this existence by God in his image. So we should be in the middle. But heliocentrism, discovered with these new telescopes and these scientific observations, disproved all of that. Now, it was so important to the church to hold on to geocentrism that I was telling you Galileo was persecuted. So they told him, you're ordered to publicly recant your testimony. That means go out in public and tell everybody, I don't know what happened, I don't know what I was thinking, but I said heliocentrism and maybe Satan or somebody must have got into my head because no, never mind, I didn't mean that. And he did have to recant his testimony because they were threatening to punish him with execution. Now, centuries have passed. And in the time period since then, even the Catholic Church has come back and like issued formal apologies to like his descendants and stuff, because it's an undisputed fact that everyone knows today that the sun is it's indisputably at the center, and that's been measured, recorded, and shown with detailed proof. But back then, it was a subject matter of big controversy. So anyway, Copernicus is one of those founding father type of figures of Western science. I've heard it described that it was so revolutionary, this idea that the Earth is not in the middle, that sometimes it's called the Copernican revolution, the idea that we're just a part of the universe but not the focal point of everything. Okay, there's also another interesting figure of early science that the textbook mentions here. I mean, there's so many more. You could talk about Johann Kepler, who determined that we move elliptical orbits around the sun. Talk about Isaac Newton, who discovered physical principles, Newton's laws, force equals mass times acceleration, all that kind of stuff. So there's a real grab bag of options, but they just chose to also mention Sir Francis Bacon. Okay, so Francis Bacon, Sir Francis Bacon, because he was knighted by Britain, so an esteemed citizen of England. He lived from 1561 until 1626, and he was British. He is known for formulating the steps of the scientific method, and so that's his kind of legacy. Okay, so the scientific method, we'll talk a little bit about that. It maybe today or maybe on Monday if we don't get to it yet. But the scientific method is something that probably a lot of you have learned about because it's considered, I think, a very primary lesson in even basic science classes that you take in like high school and even before that. The scientific method begins by observing something in the world and then wanting to know how it works or what's the cause. Then after that, you provide some hypothesis, which is like an initial attempted explanation for the occurrence of the phenomenon. And then you try to provide some test that can test the hypothesis. And this test is either going to confirm or disconfirm the hypothesis. And so then you'll know whether or not you have the right explanation by means of the test. So those steps that go in that order were sort of first formulated in the writings and the research of Sir Francis Bacon. So we owe him a big, I guess, historical debt as well because of the prime importance of taking those steps when you do scientific research. He said, discover truth by direct observation, test, and experiment. I think famously, one example of the kind of method that was used here in an early scientific experiment during his lifetime was, okay, so how like if you leave food out somewhere and you just allow it to rot, that maggots and stuff will perhaps come to it and start like feasting on the food, and it's kind of gross, right? If you go to like an open dumpster or something, you look inside, sometimes you see all these little bugs. Okay, so in one case during this time period, people had noticed that rotten food, rotten meat, it seems to have spawned these maggots and so forth. And people at that time, not everybody understood what's causing these things to happen. So in their relative level of ignorance about how these things worked, some people had the following idea. Well, meat and food, when it rots, it turns into the maggots. They thought it's the food itself that becomes these weird little bug-like looking creatures, So you understand the hypothesis is, what's the cause of the maggots? Oh, it's the food that rots and putrefies, transmogrifies, turns into these little maggot-looking beings, which of course is not true. But how would we test that hypothesis if it's the food turning into it itself? How do you think we would test that explanation for the presence of these weird-looking little, you know what I mean, bugs, insects, or whatever you want to call them? If we wanted to test this, the explanation which says if the food has turned into it, how do you think we could test that? It's actually quite easy. If you have a thought, you could throw it out there. If not, I can easily just tell you. Observe the food, yes, you have to observe it. So you start off with the food when it's fresh. You just put it there when it's fresh. But then you have to have two cases. Okay, so you have to have a control set, and then you have to have other dependent variables. So it's take the food and cover it with an impermeable barrier, right? So I don't know, in the modern day case, that would be take the food and cover it with saran wrap or aluminum foil so it's tight and so that nothing can get in. You know where this is going? So you take one of these sets of food and you cover it with that, take another one, and you leave it wide open, right? Now, if your theory is correct, that when the food rots, it just turns into these things, then what should be the predicted result from setting up this experiment? Well, according to the hypothesis anyway, what you should see is that the food which is completely covered and sealed, if you just let it rot long enough, that it will turn into these weird-looking maggots. But of course, once such experiments were conducted, we learned that that's not how it works. And so it was easy to determine after that that there's some type of organism in the environment which deposits larvae, and that's how this happens. But if you deprive any outside force the ability to access the food, then it's not like these things will just spontaneously generate out of thin air. Okay, I don't know. I'm raising just an old classic science experiment to give you a sense of the kind of procedure and method that Sir Francis Bacon kind of ushered in for us. Okay, well, as we've now talked about some of the early important figures in Western science, we're going to move on to start talking about what are some of the big fundamental assumptions that are built into science, assumptions that are behind science. Okay, so okay, so there are some fundamental assumptions that science and the scientific researchers have to make in order for science to even be conducted. So these are like very just baseline fundamental assumptions, givens, that the scientist says has to be assumed. All right, so one of them is empiricism. Now, you already kind of know a little bit about empiricism because it appeared earlier in our class also when we talked about knowledge. So what is empiricism, if anyone can recall the term? The definition of empiricism is what idea? Let's hear that. If you could tell me that one in the chat. Empiricism is the view, something about where our knowledge comes from. You could tell me that. Just let me know. Yeah, everything comes from the senses. Pretty much, well, to be more specific, it's that most human knowledge comes from the five senses and from observation. Okay, so let me just define it again, even though it's somewhere in your notes. It's this view. It's the belief that most human knowledge comes from the five senses and observation. Okay, so empiricism does claim that most of our knowledge comes from our five senses and from the things that we can observe either directly or indirectly by means of the five senses. Okay, so yeah, according to this viewpoint of empiricism, we got to use our five senses and observe the world, and that's how we're going to know things. That's really at the heart of science too, because science is all about observation of facts, then the creation of hypotheses to explain the observed facts, and then conducting tests to check to see if the hypothesis is true. So science crucially revolves around conducting observation. And when you observe things, you're using your five senses, right? They're like seeing, tasting, touching, hearing, or smelling something. Sometimes scientifically, we use tools to enhance our ordinary powers of perception. So, like you're looking through a telescope, well, that's vision enhanced by the functioning of the telescope, or a microscope, same idea. Or, if you have like infrared goggles on, a night vision or something, that is another way of modifying the quality of your vision for a particular purpose. If somebody has a stethoscope in their ear, then maybe they can hear more powerfully by means of the enhanced sound coming through the stethoscope. So we can use our five senses to observe the world, and when we do that, and when we think most of our knowledge comes from doing that, that's the idea of empiricism. So science is all based on data that can be observed and collected through the five senses. So that's one major assumption of science. Okay, and so as we continue, a next assumption that's built into science is what's called objectivity. So this concept, a little philosophical, but let me explain. It's the belief, the idea that that we can learn about the physical universe as it really is. So we can learn about the world as it really is and without any bias. Okay, objectivity. It's an assumption of science. It's the assumption that we really can learn about the world as it actually really is objectively, and that we can get to that knowledge about how it really is without bias, without it just being an expression of our own bias or personal viewpoint. Okay, so for me to expand on this for you, let's go into this question. I want you to think about the difference between objective and subjective, okay? And just, put that in your mind for a minute, and let me ask you, which of those two kinds of statement is this? So if I tell you vanilla is the best ice cream, is that statement objective or is it subjective? Because I'm telling you vanilla is the best ice cream. So am I saying something that is subjective or am I saying something that is objective? Okay, good, Jamie, it's subjective, correct. Why is it that it's subjective? Well, because it depends on me and it depends on my own taste and my own preference. Maybe I do think that vanilla is the best ice cream, but we can't say that it's an objective fact because it's a matter of opinion. But what if I told you that, I don't know, the moon orbits the planet Earth? Is that subjective or is it objective? Or that we're the third planet from the sun? Would you say that's a subjective statement or an objective statement? That's objective, right? Okay, now what's the difference here? Well, because the first one has to do with how I feel and whether I think so or not. The second one, though, like the moon orbits the planet Earth, that's not just my personal feeling. That's not just like my opinion or, my bias coming out as I'm telling you what I think. Instead, that's an objective fact. So science believes in the existence of an objective world. Like there's not just you and your feelings and emotions. There's a physical world with a set of objective facts about it that we are capable of discovering if we just use reason and if we just use our brains appropriately. So science assumes the existence of an objective reality that we can learn about as it really is. So science believes that when we come to these conclusions scientifically, we're not just talking about our feelings and we're not just talking about our personal biases. The scientist assumes that we are getting to objective truths, that there is an objective world and that we can discover how it really is simply by using the tools of reason and judgment, and that we can do that without bias. Okay? The world is something that exists independently of me and you. This world, we're a part of it, sure, but we're not the whole thing, and the world is bigger than us. So we think there's an objective universe/world that we are capable of learning about in science. If that wasn't true, then there would be really no point of doing science. I mean, imagine if you thought there's no way to get to the truth. There's no objective truth, and we could never find out what it is. If that was the case, then there would be no real reason to even try. If we just thought we're hopelessly trapped within a bubble of our own personal opinions, and we'll never really know what's objectively true, then we would have to just say, well, forget about science because the conclusions the scientists reach aren't even really true. They're just sort of his feeling about it. So yes, scientific claims can be debated. There can be evidence that shows that they're incorrect, but the goal is there, and the belief in the achievement of the goal is right at the heart of science, that we have a goal of learning about objective reality, that there are truths that are out there, and that we can get to those truths if we just use reason. Okay, so that's another one of these assumptions of science. And then another one, as we continue through the notes on chapter 12, another main assumption of science is what's called materialism. Now let me just explain something to you, because we learned earlier in this class about equivocation, right? That's when there's a single word that has more than one possible meaning, and the meaning can change depending on the way that the term is being used in an argument or in a conversation. Now materialism, there are sort of two senses of it. We, in this class, we're only interested in the scientific sense of the term. But there is a sort of other sense of it that I don't want you to be confused by. So let me just say this. Materialism, if you want a second label for it that avoids this ambiguity of equivocation, you can also think of it under the label of physicalism, which in my view is actually the better and more appropriate label. But anyway, the textbook is going with materialism as the chosen name, and so I'm just letting you know, materialism, or sometimes it's called physicalism, it's this view. It's the view that everything in the whole universe is made out of physical matter, including, and this is key, including us, including me and you and our consciousness. It's all just made out of matter. So that's what physicalism or materialism says. So okay. There it is. That's the definition of this concept. That everything in the whole universe, not just some things, not just most things, but every single thing, 100% of everything, is just made out of physical matter. Now, about the term physical matter, what do you think is the scientific term for the most basic physical constituent of matter? You know, like, so if you take a physical table or a person or anything, something that's got mass, and you split it down to the least element, what do they call those tiny building blocks? Yes, we'll get to that, Jamie. Yes, the answer is yes. Consciousness and thoughts, your feelings, and so forth that you're having right now. But to my question, good Clarissa, the atom, also same with Kenny. Now you say cells, Judy, but not quite, because the cell is the most minuscule element of, well, to be honest, you can further divide the cell, and there's things within it like mitochondria and stuff. But living matter, like biological matter, has the cell as one of its primary constituents. But in things that are not alive, like, you know, just, I don't know, like a piece of metal or whatever, you don't see a cell, but you do see atoms. Okay, so atoms, I was thinking, would be the most apt thing to associate with physical matter. So anyway, materialism is saying the following idea, that everything in the world, in the universe, 100%, all of it, is basically made out of atoms. So what is a physical object? Like, I don't know, this marker. This marker is just an arrangement of atoms all put together in a bundle of a certain shape and size and mass. You know, and like, atoms are very small. So like at any given time, maybe there's like a couple of them that are just sort of coming off of its surface. Over time, it would decompose. But for now, you know, it's got this solid mass, and that's what the marker is. But also, according to physicalism, or you could call it materialism, we are physical objects as well. And so we are just made out of all atoms. According to the idea of materialism, there's nothing at all in the whole universe that is non-physical. So everything is physical, and there is nothing that isn't. So one thing that this would, I guess, reject would be the existence of like an immaterial soul or a spirit, like the idea of consciousness existing after one is dead or whatever, like in the afterlife. Because if materialism is true, then what is your consciousness? Well, it would be a physical byproduct of the functioning of your brain. But if the brain was not capable of functioning, or if it had been destroyed through decomposition, as of course that happens after death, then there's no object to produce the consciousness that you're experiencing. So, I mean, according to materialism, there's nothing spiritual or supernatural going on at all. The fact that you're alive and thinking is just because of the physical operations of your nervous system and brain and the neurons and synapses firing up there. And even if it's a quite complex physical process that generates your consciousness, it's still just all physical all the way down. So, you know, a hardcore scientific realist rejects all supernatural claims, rejects the idea of the spirit or soul, and, you know, you're just an object. I mean, albeit a highly interesting, special, unique object, a living thing, especially with a human consciousness. But, you know, as science would argue, at least theoretically, at least in terms of the methodology of science, there's nothing that is unobservable that's supposed to be claimed as real. And so what we can see you're made out of is matter. And it's true, if we get into the cells of your body, then we could look at their molecular and atomic composition as well. But there's nothing in the whole process that, according to the scientific description, is something other than a physical object. So it's key to the concept that we don't just say like tables and chairs and asteroids and stuff, they're all made out of matter. But across the board, 100% of everything, including me and you, and even what it is to be a conscious being, like able to perceive, think, you know, hope and dream, feel anything, that's because of the brain, and it's a physical brain. You know, where is consciousness at? Is there consciousness in the marker? Well, no. And we can all understand that this marker doesn't have thoughts, feelings, perceptions. But why not? Well, it's not a magical explanation. It's because it's not got a brain. And if you don't have a brain and a central nervous system, then consciousness can't exist. So how could consciousness, according to scientists, I'm kind of just playing devil's advocate, right? But if you believed in this idea of materialism, your intuition would be, how could there be some non-physical basis for consciousness and thought? Like, can a consciousness just be disembodied, floating free from a physical body? It doesn't seem like that's conceivable, at least to a person who's steeped in the assumptions of science. So that's the idea here. Now, I mentioned that I sometimes prefer to use this label because it avoids false associations with another unrelated meaning of materialism. So is there a word of materialism that you have heard before this lecture where you had a different understanding of it? I think there may be. And I know that because sometimes if I ever ask this question to students, they give the wrong answer. They'll be like, oh, yeah, materialism, like a person who only cares about, do you know this other meaning? Totally unrelated to the significance in this sense of the definition. But materialism is sometimes a word that people use to refer to what? Have you ever heard that? Like, who's materialistic? Or who is overly materialistic, and materialism is how they live? Yeah, money or wealth. Yeah, of course. So sometimes materialism is used in an unrelated sense to refer to people who only care about physical possessions or money or how they look. And you know, you say, oh, that person's so materialistic. They need to not have such materialism. They should be more real. But that's not the meaning of it as it's applied to this topic. So just understand, we are not talking about people who just want to have a bunch of nice clothes and a bunch of nice possessions. We are instead talking about the concept of everything being made out of physical matter. So matter is the root here of materialism. But if that confuses anybody, then physicalism is, I believe, a more appropriate title, because physical is right there in the name, and we don't have to worry about which kind of materialism. Is it the superficial, pleasure-seeking type of person that's the materialist that we're talking about, or the scientific assumption? So we're just here referring to it in the scientific sense. Okay, so that's another big assumption of science. And then we continue with a few more. So there's also the assumption in science of what is called predictability, okay? Predictability, so this is the assumption that the universe overall is orderly and predictable. So what that implies is that if we have figured out what a certain causal relationship is, like we've figured out how a cause-effect relationship functions, then that causal relationship will be repeatable. And it won't just be repeatable once or twice, but it would be repeatable forever and for the rest of time. So that's the assumption of predictability, that the universe is orderly and predictable, and that means that established cause-effect relationships will be repeatable and will hold forever. Okay. Predictability. So here is another basic assumption that's right in the foundations of science. Science assumes also a predictable and an orderly universe. So if the universe is predictable, that means that cause-effect relationships are reliable, that they repeat, and that they don't stop functioning that way just because of the time or the space that we're in. So let me give you a quick, I hope, fair explanation of that. So you see that there's a marker in my hand right now, and I'm just telling you something that I'm about to do. So I have the marker graphs. I want you to tell me if you can predict what would happen if I do that, because I have not done it yet, but I will, and maybe you can predict the future. So what's going to happen in this future when I release this marker, or if you were to take a wild prediction? What could it be? What will happen? What do you think? That's a question for you. Just let me know. It'll fall on the table. Okay. Are you sure? Let's see. You really don't know, I guess, until we see. But let's see. Ah, it did. It fell. It fell. Now, how did you know that? How did you know that would happen? I mean, because I didn't do it until after I got your prediction. How did you know? What made you so confident that that's what would happen? Well, cause and effect. Good, Clarissa, but I'm playing devil's advocate, so just bear with me. But what's the cause and effect? That if I release the marker, then it falls from a standing height? What makes you think that that cause and effect is going to happen? I mean, what makes you think that will be the effect? It's happened before. Okay, cool. It has happened before. How many times? Well, in every case that we've ever seen, you know, when such an object has been released from a freestanding height, it has always fallen. But I'm going to press on this a little bit more. Isabel, you say gravity. Sure. But that's part of the assumption that we have here. What makes you think gravity will continue working? I mean, it's worked so far, but what makes you think it'll work next time? How can you really know that? I mean, gravity worked all the way up till right now, but what if it just stops right now? How can you predict that it's going to continue? How can you predict that the cause-effect relationship is not going to change right now? Well, in a way, you just have to assume it. That's the point. Science just assumes that stable cause-effect relationships are not just random things that change out of nowhere, but they continue. So I dropped the marker once. Would you be willing to predict that if I drop, well, I shouldn't say drop, but that if I release it, that it will drop again? Yeah, I'm sure you'd be willing to make that prediction. And so let me ask it in a different way. If I had an infinite amount of time, wouldn't that be great? But if I had an infinite amount of time and I could just sit here lecturing to you forever, wouldn't that be beautiful? But if I could, and I could keep just dropping or opening my hand over and over again, for how long would the thing keep falling? Would it do it for the next 24 hours if I kept doing it, next 48 hours? What if I continued doing that stuff for like a week or a month? For how long would the pattern keep repeating? According to your intuition. I mean, of course, we don't have that much time, but what would happen if I had the means to do that? I'm talking about like opening my hand with the marker standing up for however long. How long do you think that that pattern would keep on repeating? A day, 2 days, 3 days? You want to give me a number of days or years or months or what? It's not a guess, it's just your thought. What is your thought? Your thought. Like, how long do you think that that would keep on happening? Well, it's a question mark to your own thought. I mean, you're the one saying it. Yeah, so I would argue probably, doesn't it seem immediately obvious to everybody that, yeah, it seems like it would just keep going on forever? Because the law of gravity, how long do you think the law of gravity is supposed to last for? Well, we can't prove that it will always exist and it will always work the same way. But in science, we just assume that natural laws are universal and that they're permanent. Okay, so the idea is once we've understood how gravity works, it's not like we just understand how it works for here and now and all bets are off tomorrow. Maybe gravity will just throw it out the window tomorrow and that principle will no longer apply to reality. Scientists believe that once we discover like objective truths about the universe and about cause and effect, that we've got something that we know which will continue to work in the same way forever. Okay, so like the electrodynamics of moving bodies, Einstein's theory of relativity. If this theory is true, it governs the behavior of objects, not just now, but as they ever would be in the future for all time. Same with like Newton's physical laws, right? We're talking about gravity. So, you know, massive objects attract one another. You know, the surface of the Earth has enough mass that this thing wants to like kind of be a part of it. If I release it from my grasp and I don't have any kind of force being used to keep it suspended in the air, the thought is that that's something that, since we know how gravity works, it works today, it works tomorrow, and for all time. It's not like in a week, when I open this hand, it turns into a chicken and it flies away, and something completely random that we never thought would have ever happened. We just assume in science that the universe is so predictable that it doesn't act in a way that is deviant or unpredictable. Once we understand these cause-effect relationships, that's it, and that's how it would always be. Furthermore, suppose we had another planet that was like of a similar mass and volume as this. Suppose I could go over there, and I took a marker with me, and I said, let's see if this happens on this planet. Well, according to science, physical laws are not just permanent, but they're also ubiquitous, meaning that they extend throughout all space. So it's not just like on the planet Earth that gravity has that property, but the same kind of phenomenon would occur here, there, or anywhere where we would reproduce the same physical conditions. Okay. Now, if we did not assume predictability, then science would really have no ability to explain anything, because we would just say, well, we've explained something, but only temporarily. When the physical laws start to change, then this explanation will no longer work, and we'll have something completely different. But at least as science conceives of itself, it's learning objective truths that are permanent and universal and immutable, meaning they don't change. They don't change, they don't vary. If we know how entropy works or gravity or anything else, that's something that we know about working here, there, and everywhere, and now, tomorrow, and for all time. Okay, so that's the predictability assumption of science. To add one more. And then finally, there's one more that's mentioned, and that's the assumption of unity behind science. Okay, so the unity assumption is that the universe as a whole is unified in a certain way. Like there's a unity to the universe, meaning that there is a single set of scientific laws and principles that could explain everything in reality. Okay, so there's one set of physical laws that could explain all things, and in that sense, there's unity to the universe. It's not like we have to have two separate sets of laws to explain two separate parts of reality. So there is an underlying unity to the universe such that everything can be explained according to a universal set of scientific laws. Okay, so I'll have to maybe mention for a moment an interesting debate or consensus position in science, which is that scientists in the field believe that even if we haven't gotten there yet, eventually in time, we will reach a point where we have one set of scientific laws and principles that we could use to explain everything in reality, to explain phenomena from the biggest, largest scales of description, like galaxy superclusters and how they function and how they operate, all the way down to the most infinitesimal levels of description, like quantum particles and elementary particles and how they propagate through space and time. Now, the hoped-for end state of this unification of scientific laws is called the Grand Unified Theory, and so abbreviated as GUT. So sometimes this is mentioned together with that idea. The Grand Unified Theory is sort of like, anybody know literature, Moby Dick? It's like the white whale, the big hoped-for ultimate goal of science to get to that Grand Unified Theory. Because if we did have that, then we'd have one elegant set of scientific laws and natural laws, which we believe could explain every phenomena from the largest to the smallest scale of reality. But for now anyway, 2020, we haven't quite got there yet to this grand unified theory. In fact, what we do have are two different and incompatible systems to describe reality with. So on the smallest levels of description, we have quantum physics. And that does great at explaining the behavior of tiny little elementary particles. But when we get up to the biggest phenomena, that's where we use the general dynamics of the electrodynamics of moving bodies, which we got from Einstein, so his theory of general and special relativity. And for reasons that are a little too technical for us right now, there are some discrepancies. There are some contradictions between quantum physics and Einstein's theory of relativity. So it's sort of like we actually do have two separate sets of explanations for two levels of reality. But scientists believe that eventually we'll get there and we'll find some kind of bridge that bridges the divide between quantum physics and Einstein's theory of relativity. And then that would be kind of like the outlines of this grand unified theory that scientists presume is lying out there waiting for us if we could ever discover it. Because it's one universe, it's one reality. Even though there's big things and there's tiny little microscopic things, there's still one reality. And so an assumption scientists have is that it's parsimonious to assume there's only one set of laws and rules that reality operates by. And so we can hold that as like a North Star to keep trying to make progress towards in science. And so that's like a goal for future scientists and for current day theoretical physicists. Okay, so we've talked about all these different assumptions that are behind science. So the next thing that the book talks about are what are some limitations of science. Some things that science kind of, it assumes but can't prove, and which could be argued as somewhat like a limitation, something that it's unable to prove, but it has to assume is true anyway. So let me just talk about those. In my mind, this part of the chapter, which discusses limitations of science, it's very interesting, but it's a little philosophical. And so for that reason, I don't know if it lends itself to the kind of easy little like vocab item notes that are typical of a lot of things in this class. So I might have to just talk with you a little bit about it. But anyway, here's the heading of what I'm going to talk about: limitations of science. Science has some limits. What are some of them? Well, there's probably more than just a few mentioned here, but I'll just talk about the few mentioned in the book. One limitation, is that science has to assume the existence of the external world in the first place. But, I mean, technically that cannot be proven. So, okay, so I think earlier in the semester, just briefly, we touched on the writings and the ideas of the French philosopher René Descartes. You remember that? We talked about the method of doubt. Well, anyway, in the method of doubt, Descartes says, assume something's false if there's any chance it could be false. And that led us into the discussion of his work, where he says, for all you know, you could be dreaming right now. And if you are dreaming, then maybe everything around you is just a fake, illusion formed in your mind, and you're not actually gaining access to the outside world outside of your mind. Like if you're living in the Matrix or a computer simulation, or this is some kind of weird dream, then in that case, who knows if reality is actually really reality or if it's just something that's made up in your mind. But science deviates from Descartes' thought experiment by saying, no, we believe there is an external world. It's out there. It exists without your mind. It was there before you were born. It'll be there after you're gone. There's an external reality. But of course, that cannot be proven, because if there was no external reality and you were dreaming, then the dream would look just like the external reality actually looks. And so you'd have no means of determining between the two cases, whether you're in a real reality or in an illusion of one. But anyway, you could call that a limitation of science, but it's a bit esoteric. I mean, nobody seriously entertains that idea that the world is all just a dream. So if science is limited in this way, I would say it's not the worst limit, because, I mean, there are some things you can't prove, but here's something that we just have to assume is true. And I don't think too many people are thrown by the possibility of being in a big dream. Yes, it's like Inception, or like The Matrix, or like any number of other movies that follow that kind of philosophical plot line of it was all a dream, or it was all in your head kind of thing. So hopefully you're not dreaming right now and you're actually in real reality. But I say that in jest, I'm saying that facetiously because I have absolutely no doubt about this. But again, it's something that science cannot prove, but we assume otherwise. We assume that it's true even though we can't prove it. I mean, imagine that you were like a character in a video game and someone's playing you from another dimension, and so you think your life is real, but this is just very sophisticated computer graphics from like alien people in another civilization. If that was true, there would be no way for you to know the difference between that and the actual case. But of course, if that was true, then there'd be no point to doing science. If you're like Mario in Mario Brothers game, there's no reason for you to like try and dissect the mushrooms that he eats to turn into Super Mario, because none of that's actually real. So science wouldn't have any point if this wasn't a real universe surrounding us and if it was just a figment of your imagination. So we have to assume in science that there is a real world, you're a part of it, but it's not created by your mind, and it's independent of your thoughts. Okay, so that's one, perhaps limit of science, but I don't find it to be the most difficult limit to just sort of set aside. Another limitation is that it's all about things that are observable, either directly or indirectly. So, if there was anything that could not be observed, if there was something that was incapable of human observation, then that would be something that would be hard for science to understand or fully grasp. So another limitation. So yeah, it would be hard for science to ever know much about things that could not be perceived, could not be observed. One area where this is mentioned as something difficult for science in the book is on the point of what's called dark matter. Okay, so take a step outside of philosophy and think of science again for a minute. One thing that seems to be true according to consensus scientific research is that the universe is expanding. Okay, so like microwave background radiation that we can monitor in the universe seems to show that all objects are moving far apart from all other objects on the cosmic scale, like not like us in our local cosmos like the solar system, but in the bigger picture of the universe, yeah, everything's expanding out. Now, one postulate is that that's the outward expansion of the universe that was first caused by the explosion of the Big Bang. But it seems weirdly to be accelerating over time, not slowing down. So it's continuing to push everything further and further out. And as some physicists argue, that if this continues unchecked, then eventually everything will be so spread apart from everything else that the universe dies what's called a cold death, because no thermal reactions or heat can be generated once everything, down to the last atom, is like far, far away from everything else. But that's far, far into the future if it even does happen. Other people postulate that there will be some kind of contraction force that ultimately starts to bring things back, maybe pulling things back into a singularity and causing another Big Bang explosion out, but that's something that's not as well understood. Anyway, another theory that tries to explain the observed phenomena of all this outward matter expanding is the idea of dark matter. Some people think that, okay, there's this substance in the universe which they call dark matter because dark means you can't see it, you can't observe it. But if it exists, maybe it has this physical property of pushing everything. And if this type of substance did exist, then that might answer some of the questions that scientists have about like what is fueling this outward expansion. The problem about dark matter is, though, it's dark, and so you can't observe it. So it's always going to be a little bit difficult for a scientist to fully capture or comprehend the concept that they're discussing in that case. In other cases where things cannot be directly observed, we can get around this limitation by finding indirect means of observation. So like a cloud chamber in particle physics is where you fire these tiny elementary particles into a big cloud chamber, and the line that is created by the movement of the particle can be observed even if the particle cannot itself. So there are ways to try and get around this limitation, but some people worry about that. And if there are those who have like views about the supernatural, souls, spirits, prayers, the divine, heaven, hell, science would have a limitation by not being able to speak on any of those things because they're not even claimed to be directly perceivable with the five senses. Okay, so another limitation of science. And just very briefly, some people also just critique the predictability assumption that I mentioned just before, that the universe is so predictable that the way it operates will always remain the same, and that the cause and effect relationships will be stable and they would never change. Like some people just say, how do you know that? I mean, even gravity, yeah, gravity seems like it keeps working, but you don't know what it'll be tomorrow. Maybe we'll wake up tomorrow and stuff will just start floating around and we'll lose track of how gravity works. So some people argue that you can't really make a claim that the whole future of time will operate in the same way as the past has because you don't have access to the future yet. So some people find the predictability assumption to be helping ourselves to too much when we posit these philosophical, not philosophical, but rather scientific explanations. There is something philosophical about science too, though, so I don't want to make it seem as if they have no overlap between each other. As maybe some of you guys know, philosophy is the father of all the sciences and all the other academic disciplines. I think I've seen a funny meme lately about that. Maybe only academic philosophy professors share memes like this, but I don't even think it's funny really. It's too academic. But the meme has like someone walking like 10 dogs or whatever, and each of the dogs is named by a different academic discipline: psychology, science, history, and then the guy walking the dog, the label is philosophy. So he's got like these 10 different dogs that have all kind of spawned from him, but the head honcho main guy is philosophy, which is true. It's the original academic discipline, and everything branched off from that. Okay, so the chapter keeps going, but I don't want to get too much of it in today since we have more material that we want to finish with on Monday. So when we come back on Monday, we'll just review what we've done here, and then we'll talk about attitudes that people have about the relationship of science to religion. We'll talk about the steps of the scientific method, and we'll talk about how to evaluate scientific hypotheses, what are qualities of a good scientific hypothesis, and finally we'll talk a little about fake science or pseudoscience, as they sometimes call it. Okay, so I'm going to let us go with that, but remember what I've said. Don't worry if you sent me an email over the past couple days. It's just been taking me a little time to get to all of them with the election and stuff. Certainly, if I haven't given you a reply yet, you'll get it back in the next day or so. I have a long stretch of free time tomorrow, so my plan is to get up kind of early and just try to go through all of them if I can. So just hang in there for a bit. But if there is anything that you need, I'm always checking my messages, and if there's anything urgent, I flag those first and try to go into them first. So anyways, guys, thanks again. Have a great one. Have a good weekend, and be in touch, okay? I'll see you back on Monday. If you have any questions about your homework assignment that you're currently working on or anything else, just let me know, and I'll be there. Okay, have a good one then. Thanks again. Bye-bye.